Okay, plan for this recording. We're going to talk through application of logarithms, and in particular two ways of typing it into our calculator, how to type in a common log and a natural log. So first of all, if your logarithm is base 10, it's called a common logarithm. Now, if it doesn't have anything written, like if I asked what is the log of 100, and there is no base written down here, it's implied base 10. That's a common logarithm. So anytime you see a log with nothing written down here, that's implied base 10. So this would be the same thing as log base 10 of 100. Okay, on my calculator, that would be this button over here on the side. Log with no base written is implied base 10. And we know the log of 100 is 2, right? Because 10 raised to the second power is 2. And my calculator does confirm that. The log of 100 is equal to 2. Again, why? Because 10 raised to the second power is 100. The answer to my logarithm is an exponent. All right, natural logs is ln. If you write ln, this is the same as log base e. So if I asked what is the ln of 42, I don't know what that is, but the answer is 2.718 to what power equals 42. So I grab my calculator and I type in ln of 42. Hit equals. And if I raise e to that power, I should get 42. The ln is just like a common logarithm. It is simply a log with a different base. It has a base of e. So anytime you see ln, you're thinking log base e. So on that note, what is the ln of e? That question is asking log base e of e, or e to what power is equal to e. So the answer should be 1. ln of e equals 1. ln is log base e. And to type it in the calculator, you just look for that button on the calculator. Okay, I'm looking for log, or I'm looking for ln. Where they're at on your calculator, you'll have to find it. Okay, on mine, they're down the left-hand side. All right. So now let's do some solving. So one formula that uses logarithms is the magnitude of a shock wave, like an earthquake, a Richter scale. So if we have this equation, m equals the log base 10 of t, m stands for the magnitude of your shock wave, and t stands for the number of times greater the shock wave is than another smaller shock wave, we can use that equation to compare earthquakes. So what if I had something like this? We'll do it two ways. I want to compare an 8.4 earthquake versus a 6.4 earthquake. First of all, let's just calculate the t value. And the t value stands for the number of times the shock wave is greater than another earthquake. But if I simply use an 8.4 earthquake, and I don't compare it to anything, then the smaller earthquake would be like just an earthquake of 1, so it's just going to be comparing it, it's just finding the shock wave's strength, the magnitude of the shock wave. So I know the magnitude on the Richter scale is 8.4, so let's plug in an 8.4 and for m. And let's have log base 10 of t. And I'm looking for the magnitude of t. So t equals 10 raised to the 8.4 power. Okay? So what if I did 6.4? The magnitude of a 6.4 earthquake is going to be 6.4, and the shock wave has a strength of 10 raised to the 6.4 power. Let's call this earthquake 1. Let's call this earthquake 2. How many times greater is T1 to T2? Well, it's 10 to the 8.4 divided by 10 to the 6.4, right? When you want to know how many times greater it is, you divide them to find out how much times bigger is 10 than 5. It's twice as big. Why? Because 10 divided by 5 is 2. So same idea. Well, do you remember your rules for subtract or dividing like bases? You subtract the exponents. And 8.4 minus 6.4 is 2. So a earthquake that is 8.4 in magnitude compared to an earthquake that is 6.4 in magnitude is 100 times greater. That's a lot. All right, let's do another way. Now, let's plug in for M the difference in the magnitude. So 8.4 compared to 6.4, the difference between the magnitude is 2. So I should write this as magnitude difference if we want to compare 2, right? If we're just looking at 1, then it's just magnitude, and T is the strength of the shock wave. So then I have log base 10 of T, and T stands for now the comparison between 8.4 and 6.4. Okay? So 10 raised to the second power equals T, right? If I switch forms, in order to solve a logarithm, I need to switch it into an exponential once it has the log all by itself. And so 10 squared is equal to T, and T, again, is 100 times greater. So 8.4 earthquake is 100 times greater than a 6.4 earthquake. Okay, so that's just a simple place where you will see logarithms used. It's like in Richter scales. Let's do a couple more solving, just real quick to get the feel of this ln stuff. What is the ln of e raised to the 4th power? What is ln of e raised to the 4th power? Well, remember my rule, properties from the last recording. I can bring that 4 down in front, right? And so this is going to be 4 times 1 because the ln of e, we already talked about earlier in this recording, is 1. So the answer to that is 4. What is ln of e to the 1/2? Well, you should understand that it's exactly the same, right? And so I get ln of e is 1. I get 1/2 times 1 equals 1/2. So basically what we're saying is anytime it's ln of e raised to some power, the answer is that power. What if I had log of 1,000? What question is that asking? 10 to what power equals 1,000, right? Do we all agree? Whoops. So it's asking 10 to what power equals 1,000. Well, let's change that 1,000 into 10 to the 3rd. 10 times 10 times 10. And so x must be equal to 3. So you should be able to handle those kind of, what's the right word? Those kind of expressions, those kind of equations, those kind of simplifying type problems. All right. I know this is a short, quick video, but that's about all I got for applications with logarithms.